In the quiet darkness between the stars, there are objects that drift for ages, shards of broken worlds, surviving fragments of ancient systems, and frozen bodies wandering alone through interstellar space. For most of human history, we never saw them, not one. They passed silently through the solar system, unnoticed and unrecorded, carrying stories billions of years older than our planet. Then, in the span of only a few years, 3 of them appeared. ʻOumuamua in 2017, Borisov in 2019, and now 3I Atlas. 3 visitors. 3 worlds not born in our sun's gravitational cradle. 3 objects that should have helped us understand what interstellar debris truly looks like. But the strange part, the unsettling part, is that instead of agreeing with one another, they contradict each other. ʻOumuamua behaved like a chaotic shard, accelerating without visible outgassing. Borisov behaved like a pristine comet, shedding dust and gas exactly as expected. And Atlas refuses to fit either pattern. When I compared the datasets, the brightness curves, the trajectories, the thermal signatures, the volatile behavior, a disturbing realization began to form. These 3 objects are not 3 examples of the same class. They are 3 representatives of completely different histories. And one of them, 3I Atlas, carries patterns we have never seen before. This story is not about speculation. It is not about extraordinary claims. It is about evidence, light, motion, chemistry pointing to differences that challenge what we thought interstellar objects should be. So let's begin at the only place a comparison like this can begin, with where they came from and what they were supposed to be. ʻOumuamua was the first, a faint, elongated object moving too fast to be bound to the sun. When astronomers traced its path backwards, the truth was undeniable. It came from another star. Its shape, its rotation, its unexplained acceleration, everything about it raised questions. 2 years later, Borisov entered the solar system. Unlike ʻOumuamua, it behaved exactly how an interstellar comet should behave. It released cyanide gas, dust, and volatiles in familiar, predictable ways. Its tail formed naturally. Its brightness tracked solar heating perfectly. Borisov was reassuring, a sign that the universe was not full of exceptions. Then came 3I Atlas, faint, ordinary, simple. Or so it seemed. At first, Atlas looked like a small inactive body. But as more observations came in, astronomers noticed something unusual. Its brightness didn't rise smoothly like a comet's. It rose in steps, clean, controlled, repeating intervals. That was the first sign that Atlas might not be the same kind of object as Borisov, nor the same kind as ʻOumuamua. It was something in between, or something entirely different. And so the comparison begins not with predictions, but with data. Shape tells us how an object formed. Rotation tells us how it evolved over time. ʻOumuamua's light curve, its pattern of brightening and dimming, was chaotic. It suggested a long, thin object tumbling unpredictably, reflecting sunlight in sharp, irregular bursts. The leading theories describe it as a shard, a splinter, a thin plate, something broken apart long ago. Borisov, meanwhile, rotated like a normal comet, slowly, uniformly, consistently. Its light curve was smooth, with gentle variation. The shape was roughly spherical or slightly elongated, but stable. A classic comet nucleus, but Atlas, rotated in a way that didn't match either object. Its light curve rose in distinct steps like separate surface patches entering sunlight one after another. Not chaotic like ʻOumuamua, not smooth like Borisov, but structured. This meant Atlas wasn't a simple body. It had large, uneven surface segments, possibly layers or plates of material that reflected sunlight differently as they rotated. Where ʻOumuamua was a shard and Borisov was a preserved comet, Atlas was something layered. This was the first major difference, one that hinted at a deeper truth. When sunlight warms a body in space, the way it absorbs and releases heat reveals its internal structure. ʻOumuamua warmed and cooled quickly, consistent with being thin, lacking depth, and having little insulating material left. This reinforced the idea that it was a fragment stripped of its volatiles long ago. Borisov warmed slowly and predictably. Its thick nucleus stored heat and released it in classic cometary patterns. This matched observations of pristine comet behavior from our own solar system. But Atlas behaved like neither of them. It warmed in zones, cooled in zones. Released heat in patches inconsistent with a uniform composition. Some areas responded like fresh ice, others like hardened crust, others like porous, radiation-damaged material. This patchwork thermal behavior aligned perfectly with the stepwise brightness curve. Atlas wasn't smooth, it wasn't uniform. It wasn't a shard, it was a mosaic, a body whose interior and exterior had been reshaped over immense timescales. This, again, suggested that Atlas carries a deeper, older history. Volatile gases released when an object heats up can tell us how old a body is, how it formed, and what chemical processing it has experienced. ʻOumuamua showed none, not dust, not gas, not even faint jets. This suggested it had been dehydrated by millions of years in interstellar space. Borisov showed abundant volatile cyanide, water vapor, dust a fresh comet with little exposure to cosmic radiation. But Atlas displayed a third category, volatiles in pockets, released at odd temperatures, inconsistent with simple sublimation. This implied the presence of ancient fractures, sealed layers, and exotic ices processed by cosmic rays for millions of years, not fresh like Borisov, not depleted like ʻOumuamua, but ancient, chemically scarred by time. Orbit, velocity, direction, these are not just numbers, they are the fingerprints of an object's past. When ʻOumuamua entered the solar system, it was moving fast to fast. Its speed suggested it had been drifting unbound for tens of millions of years, untouched by stars, shaped only by the emptiness of interstellar space. Its trajectory was clean, uninterrupted, like a shard flung across the galaxy long ago. Borisov, on the other hand, arrived with a trajectory that hinted at a younger origin. Its speed was slower. Its path more consistent with a relatively recent ejection, perhaps a gravitational interaction near its home star. Borisov looked like a fresh exile from a stable planetary system. But Atlas moved differently. Its incoming path was neither fast nor pristine. It carried subtle distortions, a slight asymmetry, a gentle deviation that suggested it had once passed near something massive. Not recently, not violently, but long ago. This trajectory implied a history of encounters, not one event but several. Weak gravitational nudges, close enough passes, environmental shaping through time. It was the motion of a body that had been wandering for ages. Not fresh, not newly exiled, but old, very old. And here, once again, the comparison rearranged itself. ʻOumuamua moved like the aftermath of destruction. Borisov moved like an object recently expelled. Atlas moved like something that had traveled across multiple star systems, accumulating changes along the way. Its path was the motion of a relic. By this point in the comparison, a deeper pattern emerges, one more significant than any individual anomaly. These three interstellar objects are not variations of a single category. They represent three fundamentally different evolutionary paths. ʻOumuamua is the fragment, a thin, volatile depleted shard shaped by destruction and long exposure. Borisov is the survivor, a pristine comet preserved from its birth system. Atlas is the relic, a layered, scarred, chemically diverse traveler shaped by ages of cosmic weathering. Three categories, three histories written in their structure, motion, and chemistry. And this is where the unsettling question emerges. If the only three interstellar visitors we have ever observed are this different from one another, what does that say about the true diversity of objects drifting between the stars? If just three examples contradict each other so profoundly, then interstellar space is not uniform. It is not predictable. It is not simple. It is ancient, violent, and diverse beyond our early expectations. ʻOumuamua showed us what long-term exposure and fragmentation can create. Borisov showed us what a preserved comet looks like. ATLAS shows us what billions of years of layered evolution can produce. Together, they imply that interstellar debris does not come in one form, but in many. These differences are unsettling not because they point to anything extraordinary, but because they challenge the simplicity of our early models. Before 2017, astronomers assumed interstellar objects would resemble solar system comets, cold, icy, predictable. Borisov fit that expectation perfectly, but ʻOumuamua broke it. And Atlas broke it in an entirely different way. This means one thing. We underestimated the galaxy. We underestimated how many worlds have shattered. How many systems have collapsed? How many icy bodies drift between stars? How many relics have survived from ancient epochs? How many strange, layered, fractured objects are passing us silently at any moment? The unsettling part is the scale of what we missed. If 3 objects can tell us this much, imagine what 300 would reveal, or 3,000, or 3 million. Our solar system may be crossed by countless interstellar travelers, most too faint to see, most too small to detect, most passing unnoticed. This comparison isn't just about 3 visitors. It's about what those visitors reveal. The galaxy is full of relics. The galaxy is full of survivors. The galaxy is full of fragments. And every one of them carries a story older than Earth. In comparing ʻOumuamua, Borisov, and Atlas, one truth becomes clear. We are only beginning to understand the diversity of objects drifting between the stars. ʻOumuamua tells us that some are stripped bare, thinned by time. Borisov tells us that some are pristine, carrying chemistry unchanged for billions of years. ATLAS tells us that some are layered, fractured, chemically evolved, shaped by ancient journeys we cannot yet trace. 3 visitors, 3 histories, 3 glimpses into a galaxy we are just learning to see. These differences are not evidence of anything extraordinary. They are evidence of something far more meaningful, that the universe is richer, older, and more complex than our early models allowed. And if these 3 interstellar travelers are any indication, the next ones we discover may teach us even more. Until then, ATLAS remains one of the clearest reminders that the universe does not owe us simplicity. It offers us diversity, it offers us mystery, it offers us complexity, and it offers us relics of worlds we will never touch, drifting silently through the darkness between stars.